Okay, so I searched it up, yeah, how to find the determinant of a 3 by 3 matrix, and now I know how to do it. Anyway, let's just do this. So it's going to be sine x into x squared minus x minus cosine x into, yeah, so it's going to be x cubed into 1, which is x cubed, minus 2x squared, okay, plus tan x into x cubed minus 2x cubed, okay, and we need to find the limit as x approaches 0 of f of x upon x squared. So all of this is upon x squared, okay. So this is just going to be sine x upon x into x minus 1 minus cosine x into x minus 2, okay, plus tan x into, oops, okay, tan x into, so x cubed minus 2x cubed is minus x cubed upon x cubed minus x, fine. And as x approaches 0, this thing approaches 1, so it should be 1 into minus 1, minus this thing approaches 1 as well, so minus 1 into minus 2, yes, and this complete thing approaches 0 because this thing and that thing both approach 0, so this should be minus 1 plus 2, which is 1. And I'm not going to talk much because last time I got pain in my throat, which is not good, so I won't talk. Next question. Oh, I realize, yeah, I think I know this format, right? So yeah, say that x is, suppose x is cotangent theta, then this thing 3x minus x cubed upon 1 minus 3x squared, this is just cot 3 theta. So we are just finding 3 theta, right? F of x is 3 theta, which is basically 3 cot inverse of x, okay. And suppose x is tan theta, then 1 minus x squared upon 1 plus x squared is 2, okay, no, not that, it is cosine of 2 theta. So here we're just finding 2 theta, right? So g of x is 2 tan inverse of x, okay, that's better. So now we know what g of x and f of x are, and we need to find this thing, okay. Limit as x approaches e of f of x minus f of a upon g of x minus g of a. Now this looks a lot like a derivative, yes. So for a derivative it was like limit as x approaches a of f of x minus f of a upon, okay, this is supposed to be like this, upon x minus a, right? That was what a derivative would be generally. And this also looks much like a derivative, except you have this g of x minus g of a over there. I guess we can do it like this. So this upon the limit as x approaches a of g of x minus g of a, oops, upon x minus a. Yeah, that looks correct. So this should just be the derivative, because these are gonna get cancelled, right? So we get the same thing. So it's just going to be the derivative of f of x at a upon the derivative of g of x at a, okay. I think that's how it's going to be. So the derivative of f of x, which is 3 cotangent inverse x, so that derivative is just 3, okay, minus 3 upon 1 plus x squared, yeah, upon so the derivative of g of x is derivative of 2 tan inverse x, so 2 upon 1 plus x squared. I think that should be the answer, but I won't be surprised if it's not the answer because this question is very complicated, so yeah. Anyway, next question. So limit as x approaches 0 of tan x into 1 minus cosine x upon 1 plus tan x into x cubed. Wow, this is gonna take time. 1 plus tan x, that thing is Sin x plus cosine x upon cosine x. No, that's not gonna do. You have that upon cosine x over there. Think. Okay, x approaches 0, so tan x also approaches 0. This thing goes to 1. Right, so we need to get that out first of all. I think I know how to do it. So it's like tan x upon x, and 1 minus cosine x is 2 sine squared of x by 2 upon x squared. Okay, all of that upon 1 plus tan x. So this is going to be tan x upon x into, so yeah, I think it's 1 by 2. Okay, wait a second. Yeah, x by 2, right? So in that case you have 4. This should be 1 by 2. So 1 by 2 into sine x by 2 upon x by 2 squared, right? Yeah, that looks correct. Upon 1 plus tan x. Now this thing approaches 1, this thing also approaches 1, and this thing also approaches 1, as this should just be 1 by 2, right? Next question. Or it could be like it does not exist. No, it can't be like that. These are all continuous functions. Next question is, if limit x approaches 0 of 2 into e minus 2x minus tan x upon x squared sine 2x. Wow. E minus 2, that's just a constant. Minus tan x. Alright, that's weird. So tan x upon x, and then right, this is actually very doable. Correct. So this is just 2 into a minus 2 minus tan x upon x sine 2x upon x. So we can write this as 2 sine 2x upon 2x. So this thing approaches 1, this thing approaches 1, so it's just going to be 2 into 2a minus 4 minus 1 is 0, right? So that means a is 5 upon 2. Cool. The next question. Upon h squared, isn't it? I think. Oh, it's a 2 over there. It's really weird. So now we're talking about squares and everything. Okay, fine. So this is going to be log base e of 1 plus 4h upon 1 plus 4h plus 4h squared. Okay, I think this is somewhat doable, right? And all of that raised to the 1 upon h squared power. Let's call this thing as 1 upon L. So 1 upon, okay, let's say that the limit as h approaches 0 of this thing, that's going to be L. So L is limit h approaches 0 of 1 plus 4h upon 1 plus 4h plus 4h squared to the power of 1 upon h squared. So that means 1 upon L, that is the limit as h approaches 0 of 1 plus 4h squared upon 1 plus 4h. Okay, this is weird. And then you have 1 upon h squared. So maybe we can say this thing is u. This is limit h approaches 0, 1 plus u to the power of 1 upon u, all that raised to the u upon h squared power. So this is going to be e to the power of limit h approaches 0. U was just this thing, so it's going to be 4h squared upon 1 plus 4h squared into, oh, it's 1 plus 4h, and that into 1 upon h squared. So this cancels. So this is just e to the power of 4. Nice. That's really nice. This is just e power 4. And that means L is e power negative 4. Yeah, because a reciprocal. So this thing is like just limit h approaches 0. Okay, so L is e power -4. So log base e of e power -4, that is -4. So that should be the answer. Next question. Okay, x goes to a. Natural log of 1 plus x minus a upon x minus a is x goes to a, so x minus a approaches 0 basically. This is very doable, right? This is very doable. Just say x minus a is u. So this is like limit u approaches 0, natural log of 1 plus u to the power of 1 upon u. Hey, this is very easy. This is just 1, right? Next question. Oh, that's weird. This is like log base 10 of e, isn't it? Yeah, that should be the answer. Wait a second. Just wait a second. Better now. Okay, so let's do it like this. Log. I think by log they mean natural log. I don't know. So just write natural log instead. Okay. This is the limit when x approaches 0. Okay, fine. Can we kind of, yeah, we can do that. This is going to be natural log limit x approaches 0 of 1 plus 4x upon 3 minus 2x to the power of 1 upon x. Okay, which is natural log limit x tends to 0. This is like 1 plus u to the power of 1 upon u times, okay, all that is to the power of u upon x. Okay, which is natural log of e raised to the limit as x approaches 0 of, what was u? U was this thing, 4x upon 3 minus 2x times 1 upon x. This cancels, so put x equal to 0 into this thing, so you just get 4 upon 3. This is natural log of e to the 4 upon 3, which, you guessed it, it's just 4 upon 3. Nice. So that's nice. It's 4 upon 3. What else do we need? The limit as x tends to 0 of e to the 2x minus e to the x minus x upon x squared. Okay. Oh, we didn't mark the answer. We should be marking it. Right. That's weird. Let's e to the x minus x squared. Okay. Now, how can I do this? Think. Okay, what about e to the x squared, right? So e to the x into e to the x minus 1. Okay, this is not gonna work. Just put 0 into that, we get a 0 by 0 situation. So let's just start taking the derivatives. Right. L'Hopital's rule is always a good thing to do. So it's going to be 2 e to the 2x plus e to the x minus 1 upon 2x. Still nothing, right? It's still 0 by 0. So take another derivative. So it should be 4 e to the 2x minus e to the x upon 2. Now it's something finite. So put x equal to 0 into this thing. So just get 4 minus 1, which is 3. So this is 3 by 2. Easy. This thing can be, the thing can also be done using Taylor series. Next, we have the value of limit x tends to 0 of e to the x minus 1 minus x upon x squared is, okay. Is this a 0 by 0 situation? Yes, it is. So yeah, just take the derivative. So e to the x minus 1 upon 2x. And then this can be written as e to the x upon 2, which is 1 by 2. No problem. Next question. Yeah, I guess this is completely correct. Next question. X tends to 0. Oh, okay. Once again, this is a 0 by 0 situation. Okay, fine. So just take a derivative, right? Yeah, that is our general strategy now. So this should be 2 power x natural log 2 upon the derivative of this thing is 1 upon 2 square root of 1 plus x. Yes. And then minus 1, that thing is just 0. So this should be 2 power x natural log 2. Okay, so it should be x plus 1, but let it be 2 into 2 power x natural log 2 square root of 1 plus x. And now try putting x equal to 0 into this thing. Yeah, it's going to be 2 natural log 2. Easy. So 2 natural log 2 is basically just natural log 4. And A should be the correct answer. Next question. X approaches infinity of x plus 4 upon x. Yeah, this is doable. I've seen a lot of these questions. So this is just 1 plus 3 upon x plus 1 to the power of x plus 3. Call this thing u, so it should be 1 plus u to the power of 1 upon u to the power of u times x plus 3. And now this thing just approaches e, and if this thing approaches some finite quantity, then we're good to go. So it's like e raised to this thing. So what's this thing? u was this 3 upon x plus 1, this times x plus 3, and it's as x approaches infinity. So this thing just approaches e power 3 because this thing is going to approach 3, right? Yes. So it's just going to be e cubed. Okay, x tends to infinity, 1 plus 1 upon a plus bx. Okay, fine. I think we can go for an even better generalization. Yeah, but let's not do that. We'll do that in some other video maybe. Okay, so this is going to be 1 plus 1 upon u raised to the 1 upon u times, okay, this all thing raised to the power of u times c plus dx, right? So this thing just approaches e, so e to the power of, what's u? U is 1 upon e plus bx. X tends to infinity, so this 1 upon e plus bx is tending to 0, so we can do this. And then c plus dx. So this is just e to the limit as x tends to infinity of c plus d times x. Wait, okay, this dx is not that dx. Okay, whatever. So just divide by x. So it should be d plus c upon x upon b plus a upon x. So d upon b, right? That should be the answer. So this thing is just e to the d upon b. Right. Yeah, that's correct. Next question. The limit as x approaches 0 of 2x to the power of 3x is... Oh, alright. So this is a 0 power 0 situation, which is not good. Yeah, so now what do we do? Okay, this is weird. X is approaching 0, huh? Wow, I've never seen this before. X power x. Okay, this is really weird. You know, maybe we can do this thing. This can be written as e to the 3x natural log 2x. I don't know. I'm just trying to do it. Okay. And then as x approaches 0, this thing approaches 0. But then this thing is approaching negative infinity, which is not good. This is an endless loop. Okay, this is a very weird question. I've never seen this before. What should we do? What can we do maybe? So applying natural log won't do much. This is also not a 0 by 0 situation, so no, not gonna work. I think I will leave this question and I will go for the next one, because this is something which is weird, and I have never seen this before, right? So I just don't know what it should be. Yeah. Next question. limit x tends to 0. I mean, I think this x power x thing is not defined. I don't know. Yeah, I really don't know if this thing is not defined. Maybe. Hey, can we do it like, okay, wait a second, x power x plus 1 upon x. Okay, wait, this might just work. I don't think it will, but who knows, maybe it will. So here's what I'm going to try. This is going to be 2x to the power of 3x plus 1 upon 2x. Okay, so here we're getting a 0 by 0 situation. No, this is, okay, wait a second. Yes, this is a 0 by 0 situation. So now we can just take a derivative. Okay, so the derivative of this thing, yeah, it's a slight complication, but still, just try doing it. So derivative of 2x to the power of 3x plus 1. Yes, that's what we are trying. So d by dx e to the natural log of all this, so it should be 3x plus 1 natural log of 2x. Now it's easy. This should be e to the 3x plus 1 times natural log of 2x times the derivative of all this stuff. So the derivative of this thing is 3, so it should be natural log of 2x plus, what's the derivative of this thing? It should be 1 upon 2x, right? So 3x plus 1 upon 2x, but that thing times 2. Okay, fine. So that's what this should be, and we also have to divide by the derivative of this thing, so it should be that upon 2. So e to the 3x plus 1 natural log 2x, which now I can just return to the same thing, right? So this is just 2x raised to the 3x plus 1 times 3 natural log 2x plus, now this thing I'm going to write as okay, this 2 cancels, right? Isn't that so? Yeah. That's weird. Yeah, that is kind of weird. Okay, whatever. So we just get 3 plus 1 upon x, right? Yes. And this is as x approaches infinity, or what? Oh, x approaches 0. Oh, then we cannot do this thing. Then we just have to go for 3x plus 1 upon 2x. It's approaching 0, right? So this is gonna get really bad if this approaches 0, because yeah, we're gonna get something which is not defined over there. So now everything is divided by 2. So okay, fine, this thing approaches 0. Okay, and this thing approaches negative infinity. Oh shit, that's not nice. And this thing approaches positive infinity. Oh no. Oh no. Okay, so yes, this is like an endless loop. We are not going to get out of it so soon. So yeah, I'll just leave this for the next time. And you see, there was no requirement of these 2 and 3 numbers, because those are not even involved in this thing, right? These are not even involved with the answer. So it could be that this is actually not defined, or just have to click on none of these. But yeah, whatever. Next question. X tends to 0, 1 plus x to the power of numbers. Oh, that's e. So e minus e is 0. Oh, okay. This is a 0 by 0 situation. Right. Just hate this thing. Can we use something like the general binomial theorem? Yeah, sure, but that's just an approximation for e. So now what? Okay, 1 plus 1 upon x times x, so that's 1. This is 2. No, that's not a good thing. No. This thing does approach e. Yeah. Think. Should we just take a derivative in that case? I mean, yeah, we can, but that's not a very nice strategy. Right, this does not make sense. This does not make sense. It could be anything, right? So over here we have to use the fact that e is not a limit of anything. It's like it's it's a good constant, so it does not change much. Okay, right. So just take a derivative. Just take a derivative. So first of all, we have to change this into a better format. So it should be e to the 1 upon x into 1 plus x thing. Okay, cool. Minus e plus ex by 2 upon x squared. Right. And now we're going to take a derivative. Notice that there's e everywhere. Just take a derivative. So this should be e to the 1 upon x into... Oh shit, it should be natural log. Oh, yeah. Oops. It should be natural log of 1 plus x over there. Is natural log of 1 plus x. Okay. Derivative of this thing. Right, so it should be e to 1 upon x squared natural log of 1 plus x. Plus... Okay, whole 0 plus e by 2 upon 2x. Still, it's a 0 by 0 situation, isn't it? Yes. As x approaches 0 of this thing, this is just weird. Okay, 1 upon x squared natural log of 1 plus x. I don't know how it's supposed to work. So is this technically a 0 by 0 situation? I mean, this thing is going to... we don't know what it's going to yet. I mean, this thing is at least going to some very horrible value. It's... yeah, it's gonna go to infinity. This is also going to infinity. Then you have that over here. What? This does not make sense. Oh no. I need to think. X approaches 0, right? Maybe this is like e plus something. Okay. Okay, maybe this will work. Right, so let's try it out like this. So this should be 1 plus x to the power of... I don't know what's gonna happen, but we gotta try, right? So this is 1 upon x squared. All that rest to 1 upon x. This e upon x squared. Plus e upon 2x. Right. That is what we are getting. So... this does not make sense, right? This does not make sense. One to the power of 1 upon 0 is like infinity, obviously. That's gonna approach some finite value. Correct. So some finite value minus another finite value. Okay, that's 0. And yeah, this should be having something like x squared or something. Otherwise it's not gonna make sense. You know what, let that be. I'm gonna use the GBT now, and that's gonna give us a good answer, because this is not gonna work just like that. So, but can we really use the GBT for this thing? Because 1 upon x, right, that's not a good thing. Why? Cool, you have squares, but should also be like negative. Can you just use something like a Taylor series approximation for this thing? No, we cannot. Come on, why is this not working? Don't tell me I also have to leave this one. I guess I have to, because okay, we tried to take the derivative and we don't even know what this thing approaches to. Should this not just approach infinity? Yeah, I think it should technically approach infinity. So in that case, this is completely rubbish. This should be approaching infinity in that case, right? Yeah, well, that should be what's gonna happen. So um I don't know. I just don't know. That is a finite value. Okay. And this, okay, that's also a finite value. And oh yes, this does approach infinity. Yeah, this limit is not good. It does not give us a finite value. I'm very sure about that. Next question. Next question is okay, limit as m approaches infinity of x upon m to the power of m. Oh, cosine x power x upon m to the power of. Why? Just why do they keep giving us these weird things? Now what should we do? M approaches infinity. So x upon, okay, this is just 1. More like 1 minus something. And that thing raised to the mth power. Oh god, that's not nice. So should this just be 0 or what? No, wait, that's not gonna work. M approaches infinity, cosine of x upon m. That thing is definitely approaching 0, so this thing is approaching 1, so 1 to infinity, we don't know what that is. This could be anything. I mean, it could be 1 upon e or it could be 0. Yeah. I think it can be 1 upon e. Yeah, it should be 1 upon e in that case. Why? Why do they give us these questions? Well, just use the Taylor series approximation for cosine. So cosine of x is given by 1 minus yeah, it's a minus. So sine x is like 0 and then minus cosine x at 0 is minus 1 minus x squared upon 2 plus some other stuff, right? So this should just be 1 minus x squared upon 2m squared plus some other stuff which involves 1 upon m power 4 and all that raised to the mth power. Okay, I don't know if this is gonna work. And yeah, come on, just how can I do this? Like, this should be 1 minus x squared upon 2 and that should be 1. What is this? I mean, out of these options it could be anything. Out of this, I think because we have not yet covered these things, I don't know the answer. So just gonna move on, just going to keep moving. And yeah, to the next question. N approaches infinity of n squared minus n plus 1 upon n squared minus n minus 1. I think this is doable. This one is like a little more doable. So this should be 1 plus 2 upon n squared minus n minus 1 raised to the n into n minus 1 thing. So this is just 1 plus u raised to the 1 upon u, that thing raised to the u times all that stuff. So this should be 2 upon n squared minus n minus 1 times n squared minus n. So this is it's like n approaches infinity, so n squared minus n, that thing also approaches infinity, right? Because it's like n into n minus 1. So yes, infinity times infinity is infinity, obviously. So this is like e, and this thing is 2 upon 1 minus 1 upon n squared minus n. So 1 upon infinity, 0. So it's just 2 upon 1, which is 2. So it should be e squared. This was easy. Next question. 1 minus cosine mx upon 1 minus cosine nx as x approaches 0. I think Taylor series is gonna do, or even better, you can do this thing, right? 2 sine squared of mx by 2 upon 2 sine squared of nx by 2. Ouch. So 2 gets cancelled, so you just have sine mx by 2 on sine nx by 2 to the power of um, 2, and then we can use the small angle approximation on this thing to get m by n squared as the answer. Doable. Next question. X approaches pi by 8, sine 2x minus cosine 2x upon 8x minus pi, and 8 times of that basically. Okay, wait a second, just wait a second. Okay, sorry, there was some disturbance. Okay, so this question is sine 2x minus cosine 2x upon 8x minus pi. X minus pi by 8. Talk about that. Okay, so this can be written as like 2x approaches pi by 4. I think I know how to do this. Yes. So just go for this square root 2 times. So it's sine 2x cosine of pi by 4 minus cosine 2x sine of pi by 4. So this should be sine of 2x minus pi by 4. Okay, upon, so here we can just take that 4 common, so it should be 2x minus pi by 4, right? 2x is approaching pi by 4, that means 2x minus pi by 4 is approaching 0, and that means this complete thing is approaching 1, so it's just 8 times square root 2 upon 4, so 2 square root 2, that should be the answer. Next question. So x approaches a of x cubed minus a cubed upon sine x minus a. This is doable. This is very doable. So it's just x minus a into x squared plus ax plus a squared. Yes. Upon sine x minus a. Guess what? X approaches a, this thing approaches 0. So this complete thing is just 1. So put a into that thing. This should be 3a squared. Easy. Very easy. Next question. H approaches 0, square root of 4 plus sine h minus 2 upon h. Right. So now what? Take a derivative maybe? No, that would not be correct. I think that would be correct. No big deal, right? Yeah, but why even do that when you got this thing? So this is 2 square root of 1 plus sine h by 4 minus 2 upon h, and then we got something called as GVD. Yeah, so this is just going to be 2 into 1 plus 1 by 2 sine h by 4 plus some other stuff which has sine squared h, which we can just ignore for now, and this thing minus 2 upon h. That is, so this 2 and that 2 gets cancelled, so it's just sine h by 4 sine h by 4h. Yes, that's correct. So this should just be 1 by 4. Next question. Oops. Next question is limit alpha tends to beta of sine squared alpha minus sine squared beta upon alpha squared minus beta squared. Right. Yeah, this is also very doable. So sine squared alpha, yeah, this is gonna be sine alpha minus sine beta. I think this has to do with some concept of the derivative. Yeah, right. I think we can also do it like this, right? So multiply by 2 on both sides, so it should be cosine 2 alpha. No, not cosine 2 alpha. 1 minus cosine 2 alpha minus 1 minus cosine 2 beta. Oops, 2 beta over there, and upon 2 times alpha minus beta into alpha plus beta, which is basically cosine beta. Okay, cosine 2 beta minus cosine 2 alpha 1 alpha minus beta into alpha plus beta, and then this is just 2 sine, okay, this should be 2 over there, 2 sine of the difference, the reverse difference, which is 2 alpha minus 2 beta upon 2 so it should be alpha minus beta, and sine of the sum, which is alpha plus beta, right, upon 2 into alpha minus beta into alpha plus beta. Nice. So this thing just gets cancelled because it's approaching 1, and this thing, when you put alpha equal to beta into this thing, so this is just sine 2 alpha or sine 2 beta upon 2 beta. Okay, so this should be the answer. Nice. Next question. And this can also be done using the fact that here we are essentially taking the derivative, right? So it's basically d by d alpha of sine squared alpha at beta, and this is just d by d alpha of alpha squared at beta. Yeah, easy as that. Next question. Limit x tends to 0 of, so is this the same thing with, yeah, 2 sine alpha cosine alpha. Okay, yes, it's the same thing, right? Next question. Limit is x. Okay, wait, if this is the same thing, yeah, this is gonna work. This is obviously going to work. Nice. Next question. X tends to 0 of tan 4x minus 2x upon 6x minus, hey, we did a similar question before, right? Yeah, it was like that. Yeah, just go ahead, take the derivative. That should be fine. So just take a derivative. 4 secant of 4x minus 2 minus 3 cosine of 3x. Okay, yeah, that's correct. So now we have to put x equal to 0 into this thing. So this will be 1. So 4 minus 2 is 2. And this will be 1. So 6 minus 3 is 3. So this is just 2 by 3. Nice. Next question. X approaches 1 of this thing. Okay. If x approaches... Okay, this is a 0 by 0 situation. I guess we have to use GBT this time. Wait a second. Oh, we can do it like this. This is going to be 5 minus 5 square root of 1 plus 1 minus x squared upon 25 upon x minus 1. So this is just 5 into, and if we use the general binomial theorem into this thing, we just get 1 minus x squared upon 50, right? Yes, plus some other stuff which is not really necessary because it's very small. It's like 1 minus x squared, yeah. So all that is not necessary upon x minus 1. So yeah, this thing is 10. I guess that's correct. Yes, this does look correct. Okay, fine. So this should be negative 1 upon... Why are they giving these weird values suddenly? So we have to put x equal to 1 into this thing, right? Oh, first of all, cancel this thing and that thing and get a negative 1 plus x over there. And then put x equal to 1, so you get minus 2 upon 50. This is minus 1 upon 25. That should be the answer. Which... Oh, this is not 50, this is 10. So this should be 1 upon 5. Hey, but we didn't get a negative. Why is that? Oh, because of this negative. Okay, because of this negative, this will actually turn out to be x squared minus 1. So this is positive 1 plus x, which means yes, it's a positive. And this thing is 10, it's not 50. So it should be 1 upon 5. Next question. If f of 1 equal to 2, f dash 1 equal to 1, g1 equals to 1, g dash 1 equals to 2, then limit as x approaches 1 of g of x f of x. Oh, okay, g of x f of 1 minus g of 1 f of x is... Okay, that's weird. Okay, f of 1 is 2, so prime g of 1 is 1. Yeah, so it should be 2 g of x minus g of 1 is 1, so it's f of x upon x minus 1, and the limit is x approaches 1 of this thing. So if we just try to put 1 into this thing, we will get a 0 by 0 situation, because f of x is f of 1 is 2 and g of 1 is 1. Correct? Yes. Okay, so we need to take a derivative, so it should be 2 g prime of x minus f prime of x upon 1. That's going to be the limit. So now if we put 1 into this thing, it's going to be 2 g prime 1, which we have been given as 2 into 2, which is 4, minus, okay, f prime x is, okay, f prime 1 is 1, so it should be this thing, which is 3. Next question. Oh, it's the last question as well. Limit x tends to minus infinity, square root of x squared minus 1 plus square root of x squared minus 2. Oh, this is just rationalization. Yeah, it is rational. Wait, no, it's not rationalization, something else. It tends to negative infinity, right? Right. So this complete value is going to be something which is negative, right? Okay, so this is going to be square root of, so this complete value is just going to be something which is negative, right? So it's going to be x squared 1 minus 1 upon x squared, and we're going to put a negative over there, because yeah, because x is negative mod x, and in order to put that thing inside of the square root, it has to be a positive value, because otherwise it will not make sense. Correct? Yes. Okay, plus 1 minus 1 x squared. Okay, this is like negative over there, upon 1 plus 1 upon x, and then we can just put x as infinity into this thing, x as negative infinity into this thing. So this should be negative 2 upon 1, which is negative 2. That is the answer. Cool. So that's it. Exercise 1a is done. I mean, most of the questions at least. There are still some questions which are weird and we don't know the answers to. So I will try doing those in the next time. Okay. Until then, goodbye.